For the second part of section 5.2, we're going to start by talking about signs of our function values. So I alluded to this a little bit in our last class, but what we want to do is summarize what we know about our 6 trig functions and their location within different quadrants. So what we have found is that in quadrant 1, x is positive and y is positive, and as we know, r is always positive. We'll notice that in every quadrant. And when x and y are both positive, all functions are positive. So sine, cosine, tangent, cosecant, secant, and cotangent of theta are all positive. And that makes sense because x and y are both positive. As we move into quadrant 2 over here, now our x is negative, but our y is positive, and our r is still positive. And in this case, we just have sine and cosecant being positive. And remember, that would be because if we think about our angle, it's like this. What part is negative? Well, it's an x here. So x is on the bottom right here, and then this is our y. In this case, x would be less than 0. So our cosine is going to be negative. Our tangent is going to be negative, right? And their reciprocals will be negative. So the only things that are positive are going to be the ones that depend on opposite, or y. So y over r is the only operation that's going to be positive. Our only trig functions that will be positive are the ones that depend on opposite and hypotenuse, which is sine of theta, and 1 over sine theta, which is cosecant, right? By the same reasoning, when we move into quadrant 3 down here, if we think about this as theta, now x is negative, and so is y. So the only way a ratio can be positive is if we have both negatives, which would be tangent and cotangent only. Otherwise, since r is always positive, we're going to have ratios of r with other negative values, which will always be negative. So quadrant 3 is kind of an easier one to remember, like quadrant 1 where everything is positive. Quadrant 3 is just tangent and cotangent. And when we move into quadrant 4, if we think of our angle theta here, now x is positive, but y is negative. So the only positives that we're going to have in our ratios are going to be the ones that involve x and r, which is adjacent on the hypotenuse, which is cosine, and then 1 over cosine, which is secant. So we notice that cosine and secant are the other ones positive in the 4th quadrant. So let's determine the signs of each of the 6 trig functions for each of our given angles here. The first thing we need to know is what quadrant each angle is in. So if we think of 87 degrees, that means theta here is between 0 degrees and 90 degrees, which makes this in quadrant 1, which means all of our trig functions are positive. So sine of theta, which in this case theta is 87. So the sine of 87 degrees is greater than 0. The cosine of 87 degrees is greater than 0. The tangent of 87 degrees is greater than 0. And likewise, each of the reciprocals is 2. So 1 over sine is cosecant. So the cosecant of 87, positive. Secant of 87, positive. And cotangent of 87 degrees is positive. And that's all I'm looking for here, right? All of them are positive. What if instead we look at an angle 300? Well, if you remember our angle measures, if we were to stay on the x-axis, we would have an angle of 0 degrees. If we went up to the y-axis, we would have 90. If we went all the way back to the other side of the x-axis, we'd have 180. And if we kept going down to the bottom, we'd have 270 degrees. So what we have to figure out is which quadrant 300 is in. Well, if we went all the way around, not only would this be 0, this would also be 360 degrees, would get us around a full revolution. So where this one is going to end up is between 270 and 360, which puts us in quadrant 4. Now in quadrant 4, remember only cosine and secant were positive. So in quadrant 4 then, our sine of 300 is going to be negative, but our cosine of 300 degrees will be positive. Tangent of 300 degrees is then going to be negative. Cosecant of 300 degrees will be negative, but secant of 300 degrees will be positive, and cotangent of 300 degrees would be negative. Because again, in quadrant 4, we just have cosine and secant that are positive. But what if I split them up for you, and I now say negative 263 degrees? Well, this is where it helps to find the coterminal angle. Remember, we talked about that before. So for a negative 263 degrees, if we added 360 to figure out what our coterminal angle is, we would find that it is 97. So our coterminal angle is 97 degrees. 97 degrees would put us just past the first quadrant and into the second quadrant. So we would go 90 degrees and then just 7 more. So we'd end up something right in here. So this 97 degrees in the positive direction is negative 263 or 263 degrees in the negative direction. They are coterminal. So we can then say, okay, then we know that negative 263 degrees, right, is in quadrant 2. And in quadrant 2, we know that only sine and cosecant are positive. So the sine of a negative 263 degrees is going to be positive. But the cosine of negative 263 degrees is going to be negative. The tangent of negative 263 degrees is going to be negative. But now we know the cosecant of negative 263 degrees will be positive, because remember it's 1 over sine, and if sine is positive, 1 over positive is still positive. And then we know that 1 over cosine, which is our secant of negative 263, will also be negative. And our cotangent, 1 over tangent of negative 263 degrees, is also negative. So I would like for you to find the coterminal angle for negative 142 degrees, determine what quadrant it's in, and then determine the 6 trig function values for that angle. So you can hit pause and try it on your own, and then you can hit unpause and we'll do it together. I'm hoping you took a moment to do that. If not, you just waited for me to sit here. So let's try it. Let's add our 360 to find our coterminal angle, and we end up with 218 degrees. Well, 218 is going to be more than 90, more than 180, but less than 270. So this is going to end up somewhere here in quadrant 3. So in the positive direction, we have 218 degrees, but in the negative direction, we have a negative 142. Okay, coterminal angles. So what we know is that our coterminal angle is 218 degrees, and that puts negative 142 degrees squarely in quadrant 3. In quadrant 3, remember, this is where we had a negative x and negative y, so the only trig functions that are going to be positive are ratios of x and y, which will give us tangent and cotangent. So sine here of negative 142 degrees will be negative. Cosine of negative 142 degrees will also be negative, But this is where we know tangent of negative 142 degrees will be positive. 1 over sine is cosecant of negative 142 will be negative. 1 over cosine is secant of negative 142 degrees is also negative, but 1 over tangent, which is cotangent of negative 142 degrees, will instead be positive. It's all about which quadrant it lands in. Let's look at example 9 now. Suppose that angle theta is in quadrant 2 and the sine of theta is 2/3. We want to find the values of the other 5 trigonometric functions. So first things first, let's just draw where our angle would be. So it would be in quadrant 2, somewhere aroundish there, right? Somewhere in here. So let's see here. If we drop down our 90-degree, call this our theta, we know that sine of theta is 2/3. And remember, sine is opposite over hypotenuse. So 2 is opposite, 3 is the hypotenuse. So we need to figure out what adjacent is, so what our x is. So 2 squared plus x squared is going to equal 3 squared. So 4 plus x squared equals 9, which means x squared is 5, which means x could be plus or minus the root of 5. And if we look at the location here, when we move to the left of the y-axis, all of our x's will be negative. And so in this case, our x is going to be negative. So we're going to use x being the negative root of 5 because we're in quadrant 2. So this would be negative root 5. And now that we know what adjacent is, all we're going to do is use opposites, adjacents, and hypotenuse and the reciprocals to help us find all of our trig functions. So we know sine is 2/3. Cosine is adjacent over hypotenuse, so negative root 5 over 3. Tangent theta is opposite over adjacent. But now we have a radical in the denominator, so we need to rationalize it by multiplying the top and bottom by root 5. And we end up with tangent of theta being 2 root 5 over a negative 5. And again, you can put the negative at the top, in the front, wherever you want to put it. Let's keep going. 1 over sine is cosecant. So cosecant of theta is 1 over 2/3, which is 3/2. 1 over cosine is secant theta, so that would be the reciprocal of negative root 5 over 3, which will become 3 over negative root 5, which again, if we rationalize our denominator, we end up with secant theta being 3 root 5 over negative 5. And then the last one is cotangent theta. Well, before we rationalize the denominator on tangent, we had 2 over the negative root of 5. So if we just flip that, we have the negative root of 5 over 2. So we are using our 90-degree angle properties with Pythagorean to help us make sure we know all 3 sides. And then we're using those ratios, those and the reciprocals. 1 over sine is cosecant, 1 over cosine is secant, 1 over tangent is cotangent. All right, for example 10, I said suppose that angle theta is in quadrant 4 now, and cosine theta is 1/2. Find the values of the other 5 trigonometric functions. So we know that it's in quadrant 4, so I'll say maybe right in here. If we drop up our 90-degree, we call this guy theta. We know that the cosine is 1/2. Cosine is adjacent over hypotenuse. And we can already tell our y should be negative. So 1 squared plus y squared will equal 2 squared. So 1 plus y squared equals 4, which means y squared is 3, which means y is plus or minus root 3, but we know it needs to be negative root 3 because it's in quadrant 4. So we have negative root 3 for our y. And now that we know our adjacent, our opposite, and our hypotenuse, we can do all of our trig functions. So sine of theta would be opposite, negative root 3 over hypotenuse 2. Cosine we were already given is 1/2. Tangent is opposite, negative root 3 over adjacent 1. So we could just do negative root 3, right? So the tangent of theta is just negative root 3. And now we're simply going to take the inverse of each one, right? We're going to take the reciprocal, I should say. So the reciprocal of sine would be cosecant theta, and that would be 2 over negative root 3. And again, we're going to have to rationalize our denominator. So we multiply the top and the bottom of our fraction by root 3. So we end up with cosecant theta being 2 root 3 over negative 3. And again, you can put the negative in front of the 2 or in front of the 3 that's in the denominator, or you can put it in front of the fraction. 1 over cosine is secant, which means I have 1 over 1/2, which is 2 over 1, or 2. So secant theta is 2. And cotangent of theta, well, tangent was negative root 3 over 1, so its reciprocal will be the cotangent, which would be 1 over negative root 3. And one more time, rationalizing that denominator with the root 3. So we end up with the cotangent of theta being root 3 over negative 3. So you might have guessed by now that we can extend the Pythagorean theorem a little bit beyond what we've done so far and find a couple of other identities. And what we're going to do is we're going to derive 2 of them. We may actually do all 3 because they're pretty straightforward. But looking at this specific triangle, I have A, B, and C in place of X, Y, and Z. So you could use X squared plus Y squared equals, not Z, sorry, R. You could do X squared, Y squared, and R squared. But what we're going to do is I'm going to leave it currently as A, B, and C because that's the triangle I gave you here. Let's state our Pythagorean theorem that A squared plus B squared equals C squared. What if I said then just divide by C squared? Okay, so now I want to divide by C squared. When I do that, then I end up with A squared over C squared plus B squared over C squared equals 1. Our properties of exponents tell us this is A over C, quantity squared, plus B over C, quantity squared. Well, let's go take a look at our theta right here. A over C is adjacent over hypotenuse, which just happens to be cosine of theta. So this would be cosine theta squared. And if I looked at B over C, that's opposite over the hypotenuse, which is the sine of theta. And I will say the way that we tend to do exponents in terms of writing with our trig functions is we tend to put them with the function itself and instead write this as cosine squared theta plus sine squared theta equals 1. And I think most of the identities put sine squared first. It just so happens we did it in this order. So cosine squared plus sine squared equals 1. This is our first Pythagorean identity. So I'm trying to get to a different color. There we go. Let's try another one. Let's take a squared. A squared plus b squared equals c squared. And this time, divide by something that's not c squared. Maybe we'll divide by a squared. So let's divide by a squared. All right. And now we end up with 1 plus b squared over c squared equals c squared. Oh, sorry, b squared over a squared equals c squared over a squared. Or 1 plus b over a squared equals c over a squared. Well, let's see if we can figure out what some of these are. B over A is opposite over adjacent, which happens to be tangent. So we know that this is 1 plus tangent squared theta. And now it's equal to C over A, which is hypotenuse over adjacent. Well, think about its reciprocal. Adjacent over hypotenuse is cosine. 1 over cosine is secant. And so we end up here with secant squared. So 1 plus tangent squared theta equals secant squared theta. And as you can guess, the third one we're going to divide by b squared. So it will be a squared plus b squared equals c squared. And now divide by b squared. So a squared over b squared plus 1 equals c squared over b squared. Or a over b squared plus 1 is equal to c over b squared. A over b is adjacent over opposite, which happens to be the reciprocal of tangent, which means this is cotangent squared. So cotangent squared theta plus 1, and it equals c over b squared. Well, c over b is hypotenuse over opposite, which is the reciprocal of opposite over hypotenuse, which is sine. So this is the reciprocal of sine, which is cosecant. So we have cotangent squared theta plus 1 equals cosecant squared theta. I will say when I learned these, I learned 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. It doesn't matter what order you put them in, as long as you can remember them. So cosine squared plus sine squared is 1. 1 plus tangent squared is equal to secant squared. And cotangent squared plus 1 is equal to cosecant squared. And these are our 3 Pythagorean identities and how we derive them. This slide just shows us all 3 of them in nicely typed format instead of my handwriting. For example 11, we're going to use one of the Pythagorean identities to help us determine our other 5 trig functions when given a quadrant and a specific trigonometric value or function value for an angle theta. Instead of drawing it like we normally would, we're going to use a trig identity and see if we can do it without drawing. But we know that angle theta is in quadrant 1, which means that all trig functions, all of them, are positive. So we don't have to worry about signs at this point, which is great because all that we know so far is that tangent of theta is 2/3. Well, the nice thing we know, that means that cotangent of theta is the reciprocal, which is 3/2. We're 1/3 of the way there already. But what we don't know is what sine is, what cosine is. And in this case, we do know something interesting about tangent. We do know that tangent is equal to sine over cosine. So does that mean that sine theta is 2 and cosine theta equals 3? Do we know? The answer is actually not that simple. So we don't want to try this because we may have lost something in translation. Instead, what we also know is that 1 plus tangent squared theta equals secant squared theta. And remember, secant is 1 over cosine. So let's see if we can get to the bottom of it and see if we really do get a cosine of 3. Well, tangent is 2/3. We know that 1 plus 2/3 squared has to be secant squared. Or 1 plus 4/9 is equal to secant squared theta. That tells me that 13/9 is equal to secant squared, which means then that, here, so 13/9 equals secant squared, which tells me we don't have a cosine that's 3. We're going to end up instead here with a secant, and because we know it has to be positive, that would be the square root of 13 over 3, because when we take the square root of 13 over 9, the square root of 13 is just square root of 13, but the square root of 9 is 3. So we actually have a secant that's the square root of 13 over 3, which tells me this sine and cosine can't be that simple. But now that we know what secant is, we know that secant theta is the square root of 13 over 3, which tells me that secant is the reciprocal of cosine, which means that cosine is the reciprocal of secant. So cosine will be 3 over root 13. And when we rationalize that, we'll multiply it by root 13 over root 13. And then we end up with cosine of theta being 3 root 13 over 13. So now we have cosine, we have secant, and we have tangent and cotangent. So we're almost there. We now need to figure out what sine and cosecant are. Well, we know what tangent is, we know what secant is, and we know that tangent is sine over cosine. So if tangent is 2/3 and it's equal to sine theta, which we don't know, over cosine theta, which we do know, which is 3 root 13 over 13, what we need to do is solve for sine. Well, this is where we can do some cross multiplying and say that 3 sine theta is equal to 2 times 3 root 13 over 13. Which tells us then, I'm going to switch into just one color from here, 3 sine theta is now 6 root 13 over 13. Or sine theta, if I divide it by 3, 6 divided by 3 is 2 root 13 over 13. And now that I know sine theta, I can find cosecant theta by taking the reciprocal, which would be 13 over 2 root 13, which means, of course, we have to rationalize our denominator. And things will get a little messy this time because of all these root 13s. But we'd have 13 root 13 over 2 times 13. So the 13s will cancel, and we find out in the end that the cosecant of theta is root 13 over 2. So I know this one's a little more complicated this way. And so you don't have to use the Pythagorean identities to do this. You can still draw the picture. And in fact, we're going to do that on 3 more examples. We're going to draw the picture or try out the Pythagorean theorems. For example 12, I said, suppose that angle theta is in quadrant 4 and the cosine of theta is root 3 over 2. So if we remember, in quadrant 4, only cosine and secant are positive. So if you want to use the Pythagorean theorems to just solve for your different functions, you can. But I will say I often don't do it that way. I usually stick with drawing them in the quadrants and just using the triangle. I find it much simpler. So take it or leave it. That's how you can do it. You can do it either with the triangle or with the Pythagorean. So I'm going to do this one with the triangle first, and then we'll discuss Pythagorean. So in this case, we have our angle somewhere here in the fourth quadrant where the cosine is adjacent, root 3 over hypotenuse 2. And we can already see our y is going to be negative because it's below the x-axis. So we know that root 3 squared plus our y squared has to equal 2 squared. So 3 plus y squared is going to equal 4. So y squared equals 1, which means y is plus or minus 1. And we know that in this case, y is negative 1 because it's in quadrant 4. So we know it has to be a negative 1. So yeah, I might have given you slightly easier numbers on this one on purpose. So now that we know where theta is and we know the different measures of the sides, let's find all the ratios. Sine theta is opposite over hypotenuse. Cosine, which is negative 1, sorry, which I didn't say the numbers, that means sine theta is negative 1 over 2. Cosine was given, that is our adjacent over hypotenuse, which was our root 3 over 2. Tangent is opposite, negative 1 over adjacent, root 3. And we can see that we're going to need to rationalize our denominator here. So tangent is negative root 3 over 3. So that makes cosecant 2 over negative 1. Or that makes cosecant negative 2. Secant is 1 over cosine, so it is 2 over root 3, which means, again, rationalizing the denominator, root 3 over root 3. So secant theta is going to be 2 root 3 over 3. And cotangent is going to be the reciprocal of negative 1 over root 3, which would be root 3 over negative 1, which just makes cotangent negative root 3. To me, this is much simpler than going the other direction, which if we did cosine, we would say cosine squared theta plus sine squared theta is equal to 1. Cosine is root 3 over 2, so we'd have to square that, plus sine squared theta equaling 1. And we'll just say this is or. You don't have to do both. This would be 3 over 4 plus sine squared theta equals 1, which means that sine squared theta equals 1/4, which means sine of theta is plus or minus 1/2. And because it's in quadrant 4, we know that cosine is positive. That means sine is negative, so we would say our sine of theta here would be a negative 1/2 because it's in quadrant 4. And then you could go about finding 1 over sine. You already have cosine, you can find 1 over cosine, and you'd have to use sine and cosine to find tangent and then cotangent. So it's a little easier sometimes when you have cosines and sines because you can go ahead and find tangents. But it just takes, I feel like, a little bit longer to go this way. But if this part makes sense to you, you can absolutely do it this way. So we know cosine, we know sine, so we can find secant and cosecant. Not a problem. And then for this one, you'd want to do tangent is equal to sine over cosine. Okay, and then you could do cotangent is cosine over sine. Those are one of the other sets of identities we saw earlier. But I stick with the triangles because to me it's faster. Do what works for you. In our penultimate example, now I'm going to stick you in quadrant 2. So I'd really like for you to pause here and see if you can figure this one out on your own. Hopefully you gave it a try. We know we're in quadrant 2, so I drew an angle in quadrant 2. I'll drop down my 90 degrees. Here's my theta. I know that cosine is negative root 3 over 4. I know that my y this time is going to be positive because I'm in quadrant 2. So I know that the negative square root of 3 squared plus y squared is going to equal 4 squared. So 3 plus y squared equals 16. So y squared, 16 minus 3 is 13. Y is plus or minus root 13. And because we're in quadrant 2, we know then that y is positive, which is the positive root of 13, because we are in quadrant 2. So we'll have a root of 13. And now we'll say sine theta is root 13 over 4. Cosine of theta, which was given, is negative root 3 over 4. Tangent theta is opposite over adjacent, so root 13 over negative root 3. And here you have a couple of choices. You could combine this into one square root and just make this the negative square root of 13 over 3. That is one way to simplify this. Otherwise, if you want to rationalize it, the other option is you can say that tangent theta, if you rationalize by multiplying the top and the bottom by root 3, we end up with the root of 39 over negative 3. And it's hard to believe that that and the negative root of 13 over 3 are the same thing, but they are. When in doubt, you can plug it into your calculator and find out. So this is all by rationalizing, right? Rationalize the denominator. Or, in this case, we can leave tangent this way just by using properties, right? This is the properties of radicals. Neither one is algebraically more sound than the other. Pick your favorite. So if we continued on, sine, so 1 over sine would be cosecant theta, which would be 4 over root 13, which hopefully we're pretty good at rationalizing now, would be cosecant theta would then be 4 root 13 over 13. Right? 1 over cosine is secant. So secant theta would be 4 over negative root 3. And again, we have to rationalize our denominator. So secant theta would be 4 root 3 over negative 3. And the last one would be cotangent. So cotangent would be negative root 3 over root 13, which means we could write it as the negative root of 3/13. Again, not a problem by me. Or if we rationalize, we would have cotangent theta then would be negative root of 39 over 13. So very similar to what we saw with tangent, it just has a different denominator. And one last example, now this one we started with tangent. So for our tangent, we have tangent is 4/3 and it's in quadrant 3. And this makes sense because in quadrant 3, we know that tangent and cotangent are the only trig functions that are positive because both our x and our y are negative in quadrant 3. We know this just from graphing, which means that the only way that we can get a positive trig function is if instead we have a ratio of both negatives. So in this case, we have that our tangent is 4/3. And that means that our opposite is 4, our adjacent is 3. So if we were to draw that one in, Let's see here. I'll put that somewhere down here in quadrant 3. We'll do red this time. There we go. And let's start labeling our sides. So here's our theta. We know that opposite is 4 and adjacent is 3. But we can already see graphically that we're missing something. The ratio of 4 to 3 is the same as the ratio of -4 to -3. And we know that both x and y are negative because we are in quadrant 3. So this is really a -3 and a -4, which makes our r 5. And if you want to write it out, and if you don't remember the 3, 4, 5 triangles, that's -3 squared plus -4 squared equals 5 squared. 9 plus, oh, sorry, I'll say equals r squared. We'll solve for it. I won't give it away right away. So 9 plus 16 equals r squared. So r squared is 25, which makes r 5. So we got there. Now we know our sine theta then, and no roots this time, which will make you very happy, I'm sure. Sine is opposite, so -4 over hypotenuse, which is 5. Cosine is adjacent, -3 over hypotenuse, which is 5. Tangent was already given, opposite over adjacent is 4/3. Cosecant of theta would then be 5 over -4. Secant of theta would be 5 over -3. And cotangent of theta would then be 3 over 4. And once again, if you wanted to, you could do 1 plus tangent squared equals secant squared. It's just a longer process and requires more algebraic hoops to jump through. So I will follow up this video with another one on section 6.1, which is about radian measures.